On November 11, 2024, Google DeepMind and Isomorphic Labs released the Alphafold 3 source code as open source on GitHub. Building upon the pioneering work of its predecessors, Alphafold 3 stands as a powerful tool capable of predicting 3D structures of biological molecules with unmatched precision, especially proteins, which are essential to understanding biology at a molecular level. Alphafold 2, the model's predecessor, fundamentally transformed how scientists predict protein structures and was awarded the Nobel Prize in Chemistry in 2024 for its contribution. Now, with Alphafold 3's open source release, researchers gain unparalleled access to this powerful AI model, opening doors to new scientific and medical breakthroughs. Alphafold 3's release has immediate implications for scientific research and drug discovery, making high-level protein structure prediction more accessible to researchers worldwide. Here are some of the key ways this release will impact the field. Until now, Alphafold 3 was only available via a web server, which limited the types of prediction scientists could perform and introduced a bottleneck in scaling experiments. By releasing the source code, DeepMind empowers scientists to run Alphafold 3 directly, fostering transparency and reproducibility in their research. Researchers can now test and verify their own hypotheses independently, adding credibility to the results and enabling detailed peer review. As an open source tool, Alphafold 3 can now be used by academic researchers for non-commercial purposes, giving them unprecedented freedom to leverage the model in various scientific studies. This freedom is expected to stimulate a wave of new research initiatives and innovative applications, possibly inspiring other researchers to create complementary tools, add new features, or even enhance Alphafold's accuracy and capabilities. The release of Alphafold 2's source code led to the development of numerous tools and applications across various fields, from molecular biology to pharmacology. Alphafold 3's open source release is expected to have a similar impact, sparking the creation of new software tools and applications that build on its capabilities. This collaborative environment encourages scientists to contribute back to the tool, fostering an ecosystem that benefits the global research community. One of the significant limitations of the web-only version of Alphafold 3 was that it couldn't fully explore protein-drug interactions due to its server constraints. With open source access, academic researchers can use the model to simulate how specific proteins might interact with different drug candidates. This capability could expedite early drug discovery phases, providing scientists with powerful insights into protein-ligand interactions, which are crucial for designing effective treatments. While the open source release restricts Alphafold 3 to non-commercial use, the availability of the source code opens possibilities for companies to develop commercially licensed versions. Pharmaceutical companies may even choose to retrain the model with proprietary data, tailoring it to predict protein interactions for specific medical targets. In time, this could lead to breakthroughs in developing new therapeutics, improving personalized medicine, and enabling faster response times to emerging diseases. The release of Alphafold 3 has also spurred competitive innovation in protein structure prediction. Companies like ByteDance and Chai Discovery are developing alternative open-source protein prediction tools, pushing the boundaries of what AI can achieve in the field. While these tools face similar non-commercial restrictions, they are part of a growing open-source ecosystem that could eventually unlock commercial opportunities and further advance drug discovery and structural biology. Tether, the well-known stablecoin issuer, has just launched a groundbreaking open-source wallet development kit WDK. This toolkit empowers businesses and developers to easily incorporate non-custodial wallets into various platforms such as websites, applications, and devices. This is big news in the world of wallet technology, as it makes creating secure and flexible wallets more accessible than ever. The WDK is designed with adaptability in mind, supporting not only USDE and Bitcoin, but also AI-powered functionalities. This forward-thinking approach means it can be used by humans and AI agents, robots, and automated systems. Tether CEO Paolo Adorno highlights the importance of WDK in an unpredictable future, emphasizing its role in building programmable, open, and resilient monetary systems. The WDK is open source and built with a modular framework. This means developers can customize it to fit their specific needs and easily integrate it with their existing systems. WDK prioritizes user control by enabling self-custody of assets. This eliminates the need for third-party custodians, enhancing security and aligning with decentralized finance principles. The WDK is designed with the future in mind, accommodating AI-driven technologies. This ensures compatibility with the growing integration of AI in digital systems and caters to the financial needs of AI agents and autonomous systems. While initially supporting USD and Bitcoin, the WDK is built to handle a wide array of digital assets. The documentation outlines plans for future support of tokens on Ethereum, Tron, Ton, Avalanche, Solana, and more. The WDK documentation provides detailed information for developers interested in building with the toolkit. Here are some key technical aspects. The WDK is written in JavaScript and supports Node.js browsers in bare runtime environments. The WDK leverages industry-standard Bitcoin improvement proposals BIP like BIP39 for mnemonic seed generation, BI44 for multi-count hierarchy, and BIP84 for PTOR WPKH address derivation. The WDK provides various components for building a wallet, including wallet seed generation, generates BIP39 seeds for all assets wallet store, stores transaction history and track state wallet indexer, connects to remote blockchain data providers wallet test tools, provides tools for development and testing the documentation, provides code snippets illustrating how to set up and use the WDK for various tasks like generating addresses, sending transactions, and getting balances. The release of Tether's WDK has the potential to significantly impact the development of non-custodial wallets. By providing a robust and flexible toolkit, Tether is empowering developers to create innovative wallet solutions that prioritize user control and security. The WDK emphasis on the AI integration also points to a future where wallets are seamlessly integrated with AI-driven financial ecosystems. This move by Tether underscores the growing importance of decentralized finance and self-custody in the evolving landscape of digital assets. Technical users and data scientists working with extensive document archives. This tool, which is open source under the MIT license, provides a robust, accessible solution for transforming documents into machine-readable formats like Markdown and JSON, perfect for training large language models, LLM, and foundation models. One of the most significant upgrades in Docling v2 is its support for a broader range of input formats. Now, users can convert documents from PDF, Word, PowerPoint, HTML, and various image types into universal document representations. This new universal representation supports complex document hierarchies, simplifying the way users access, manipulate, and export converted data across formats. This advancement means that working with various types of documents becomes a smoother, unified experience, particularly useful for researchers and developers who work with mixed format data. Docling v2 also boasts an updated user interface along with new API and CLI options, which makes integration into a wide range of workflows easier and more intuitive. Whether you're a developer looking to automate document conversions or a data analyst needing a fast, effective way to process content, Docling v2's interface upgrades make the tool more user-friendly and adaptable than ever. Another impressive feature in Docling v2 is its new approach to document chunking. By enabling a more nuanced segmentation of documents, Docling v2 can separate data in contextually meaningful ways, facilitating the creation of more structured, usable training data. This type of advanced chunking is ideal for AI training workflows, as it allows large volumes of text to be segmented in a way that preserves contextual relationships between pieces of information. This sophisticated models powered Docling v2, showcasing IBM innovative research in document processing. Vision Model. IBM Vision Model leverages object detection techniques to analyze document layouts. It identifies and classifies text blocks, images, tables, and other content types. This layout detection enables the extraction of diverse content in a structured, machine-readable format. Table Former. This model specifically targets tables within documents. Converting tables from images into structured formats with rows and columns, Table Former enables AI applications to access and analyze tabular data more effectively. This feature is essential for fields where complex tabular data often exists in image formats such as finance, scientific research, and government reports. IBM has tested Docling v2 to ensure its reliability and robustness in processing large datasets. In a recent showcase, IBM InstructLab used Docling v2 to process 2.1 million PDF from Common Crawl. By converting the raw data within these documents, InstructLab created extensive datasets for training AI models, highlighting Docling's value as a high-performance data extraction and transformation tool.